In this lecture, we'll be solving applications of quadratic equations by factoring. Let's solve each application by writing and solving the quadratic equation. The height of a triangle is 3 meters less than the length of the base. The area of the triangle is 20 square meters. Find the height of the triangle and the length of the base. Well, the first thing I would do, as always, is to draw a picture. It says that the height of the triangle is 3 meters less than the length of the base. Now, we don't know what the length of the base is, so we'll call that x. The height is 3 less than the base, so that's going to be x minus 3. We're told that the area of the triangle is equal to 20 square meters, and we know that our formula for area of a triangle is 1/2 base times height. Putting those two things together, coupled with how we've labeled our diagram, we end up with the equation 20 equals 1/2 times the base, which is x, times the height, which is x minus 3. We need to get this equation into a quadratic form that can be factored. The first thing we'll do is distribute our 1/2 x. It's going to give us 1/2 x squared minus 3/2 x. Since we will be factoring this equation, it would be nice to eliminate the fractions. We can do that in an equation by multiplying the entire thing by the LCD of our equation. Our LCD here is going to be 2. So we'll multiply both sides by 2, resulting in the equation 40 equals x squared minus 3x. Before we can factor and ultimately apply the zero product property, we need to set our equation equal to 0. So I'll subtract 40 from both sides, giving us 0 equals x squared minus 3x minus 40. Now we're ready to factor. This is a trinomial with a leading coefficient of 1. We can go right to our parentheses with x's in first positions. We're looking for two numbers that multiply together to be a negative 40 and add together to be negative 3. Negative 8 and positive 5 work for us. We have two things multiplied together and they equal 0. Well, one of them is going to have to be 0. Either x minus 8 equals 0 or x plus 5 is 0. Now we need to solve these little linear equations. We end up with x is equal to 8 and x is equal to negative 5. Anytime with an application problem, you need to determine whether your answer makes sense for the context of the application. Looking at our diagram, we see that x represents the length of the base of our triangle. It would not make sense to have a negative length for the base of our triangle. Therefore, our answer of x equals negative 5 must be thrown out as an extraneous solution. Now that we've concluded that x equals 8 is an answer that makes sense for the context, we want to make sure that we have actually answered the question. They want us to find both the height and the base of the triangle. The height of the triangle we define to be x minus 3, looking at our diagram. We'll plug in our value for x, which is 8, subtract 3, we get that the height is 5 meters. The length of the base was defined to be just x, therefore the base of our triangle, 8 meters. Our next example says a stone is thrown into an empty well with an initial speed of 8 feet per second. The well is 624 feet deep. How many seconds later will the stone hit the bottom of the well? We want to use the equation d equals vt plus 16t squared, where d is the distance in feet, v is the initial speed in feet per second, and t is the time in seconds. So let's take a look at the information we have. We know we'll be using the equation d equals vt plus 16t squared. The initial speed is 8 feet per second. That's our v. The well is 624 feet deep. That tells us the distance that our stone is going to be traveling. Plugging these numbers into the given formula, we get the equation 624 equals 8t plus 16t squared. There's nothing to multiply out here, but I do need my equation to be equal to 0 and in descending order. So I'm going to subtract the 624 from both sides and put it in descending order, which is going to result in 0 equals 16t squared plus t minus 624. Now we're ready to factor our equation. I see that there is a greatest common factor of 8. I'll start by factoring that out. It's going to leave me with 2t squared plus t minus 78. We're left with a quadratic trinomial with a leading coefficient other than 1. That tells us that we're going to want to use the x method to factor this. So we're putting a times c in the top, which is negative 156, and b in the bottom, which is 1. We need two numbers that multiply together to be negative 156 and add together to be positive 1. Positive 13 and negative 12 works. We're uncombining that middle term. That'll give us 2t squared plus 13t minus 12t minus 78. And now we're ready to factor by grouping. The greatest common factor out of our first two terms is t, leaving us with 2t plus 13. The greatest common factor out of our second two terms is a negative 6, leaving us with 2t plus 13. There's that common binomial factor that lets us know we're on the right path. We have our original GCF of 8 out in front, our common binomial factor of 2t plus 13, and our last factor, t minus 6. We're fully factored. We're ready to apply our zero product property and set each one of our factors containing a variable equal to 0 and solve. Solving for t, we'll subtract 13 and then divide by 2. I get t to be negative 13 over 2. And our other solution will have t equals 6. We want to make sure that our answer makes sense for the context of our application. T represents time. We don't ever talk about time in terms of a negative number. Therefore, our solution of negative 13 halves is thrown out as an extraneous solution. Next, we want to make sure we've answered the question. The question is, how many seconds later will the stone hit the bottom? T equals 6. We just need to include our unit. It's going to take 6 seconds to hit the bottom of the well. Our next example says the outside dimensions of a picture frame are 40 inches by 32 inches. The area of the picture within the frame is 1008 square inches. Find the width of the frame. I'm definitely going to start with a picture. Here is the outside of our picture frame, and it measures 32 by 40 inches. Then we have the picture inside the frame. There's a uniform thickness of the frame around this picture. We do not know the thickness of the frame. In fact, that's what we're being asked to find. Therefore, this distance all around our picture is an unknown number. We're going to call it x. They tell us that the area of the picture within the frame is 1008 square inches. Therefore, we're going to have to write an area equation for the inside picture. I need the dimensions of the inside pictures to be able to write that area equation. We're not going to be able to use just a regular number. We're going to write an algebraic expression for the length and the width of the inside picture. Now, the bottom of this frame is 40 inches. If this part is x and this part is x, then the amount that I'm going to have left for the picture is going to be that original length of 40 minus those two x's. Therefore, this inside here is going to be 40 minus 2x. We have a similar thing happening the other direction. Again, I started with a length of 32, but then we have a length of x on the top and on the bottom that's being taken away from the overall size, leaving us with 30 minus 2x for the width of this picture. We know that area is equal to length times width. The area of the inside picture is 1008. The length of the inside picture is 40 minus 2x, and the width of the inside picture is going to be 32 minus 2x. We need to get this equation into a form that we can factor. Therefore, we're going to have to multiply this all out, combine like terms, and set it equal to 0. Multiplying this out, we get 1008 equals 1280 minus 80x minus 64x plus 4x squared. Combining like terms and rewriting the right side in descending order, we get 1008 equals 4x squared minus 144x plus 1280. The last thing we need to do before we can start factoring is set it equal to 0. So we'll subtract 1008 from both sides, giving us 0 equals 4x squared minus 144x plus 272. We're ready to factor. I recognize that I have a greatest common factor of 4. Factoring that out, we're left with x squared minus 36x plus 68. We're left with a quadratic trinomial with a leading coefficient of 1. To factor this, I can go straight to the parentheses. We're looking for two numbers that multiply together to give a positive 68, but add together to be negative 36. Negative 34 and negative 2 work for us. And now we're ready to apply our zero product property. We're setting each one of our factors containing a variable equal to 0 and solve. We get x to be equal to 34 and x to be equal to 2. We want to make sure that our solutions make sense for the context of our application. So let's check it out. X represented the width of the frame. If the entire frame is only 32 inches, the width of the border of the frame couldn't possibly be 34 inches. That exceeds the whole side of the picture frame. Therefore, x equals 34 is an extraneous solution. X equals 2 is the only solution that makes sense. Let's make sure that we've answered the question. They want us to find the width of the frame, just the border around, and we labeled that to be x in our diagram. We've solved for x. This is our answer. The only thing we need to do is put a unit on it. The width of the frame is 2 inches. In our next example, a farmer has 300 feet of fencing and wants to enclose a rectangular corral that borders his barn on one side and then divide it into two plots with a fence parallel to one of the sides. Assuming that the farmer will not fence the side along the barn, what are the lengths or the parts of the fencing if the total area enclosed is 4,800 square feet? The first thing I would do is draw a picture. So here's our barn. And we're building a corral using the barn as one of our sides, and then we're dividing it in half with that division line being parallel to two of the sides. I don't know what the width of this corral is, but I do know that these three are going to be the same length. I'm going to label that unknown length X. We have a total of 300 feet of fencing. So far, we've used up 3x of that fencing. Therefore, the amount we have left over for this bottom side is going to be 300 minus the 3x that we've already used up. They're asking us what the lengths of the fencing are if the total area enclosed is 4,800 square feet. We know that the area is equal to the length times the width. The area is 4,800. The length of our corral is 300 minus 3x, and the width is just x. I need to get this equation into a form where I can factor it. I'll start by distributing on the right side. Before I can factor, I need to set my equation equal to 0 and put it in descending order. In order to make my leading coefficient positive, I'm going to take the terms on the right and move them to the left side. I'm also going to write them in descending order. We end up with 3x squared minus 300x plus 4,800 equal to 0. I recognize that I have a greatest common factor of 3. Factoring that out, I'm left with x squared minus 100x plus 1,600. We're left with a trinomial with a leading coefficient of 1. Therefore, I can go right to my parentheses with x's in first position. We're looking for two numbers that multiply together to give me 1,600 and add together to be negative 100, negative 20, and negative 80 work. Now we'll apply our zero product property, setting each one of our factors containing a variable equal to 0. And then we solve. We get x to be 20 and x to be 80. I need to make sure that my solutions make sense for the context of my application. If x is equal to 20, that would be fine for the width of the corral. Let's make sure when we plug it into the length, 300 minus 3x, we don't get a negative number because that wouldn't make sense. When I plug 20 into 300 minus 3x, that's going to give me 300 minus 60, which is 240. That would be a fine length to my corral. All right, 20 works. Let's check 80. 80, that's a positive number, makes sense for the width of our corral. Let's make sure that we get a positive number when we plug it into 300 minus 3 times x. It's going to give me 300 minus 240, leaving me with 60, which is a positive number. That also makes sense. So let's answer the question. They want to know, what are the lengths of the fencing? Like, what would the dimension of the corral be? Well, we have two viable options. Either we could have a width of 20 with a length of 240, or we could have a width of 80 and a length of 60.